Section 4, weight calculation practice. So we write out the weight equation. W equals mg. What does each letter stand for? So W is weight, measured in newtons. M is mass in kilograms, and G is gravitational field strength in newtons per kilogram. So question 1, 2 and 3 are all low demand, so very straightforward. You're given the equation, all you've got to do is put your numbers in. So don't forget to bug the equation, put a box around the quantity that's asked for, which is the weight. Underline the given value, 65 kilogram, and you're given G, gravitational field strength. So weight equals mass times gravity, and that is going to be 65 times 9.8, 637 newtons. Number 2, calculating the weight, you're given the mass, you're given gravitational field strength, so it's 0.5 times 9.8, which is 4.9 newtons. Number 3, calculate the weight force, you're given the mass, you're given gravitational field strength, this time it's on the moon, so it's 1.6, that should say newtons per kilogram, and you put your numbers in. So it's 75 times 1.6, and that is 120 newtons. Okay, question 4 and 5, standard demand, where you've got to know the equation. So you write down the equation, bug your equations, you're calculating the weight again, but this time you've got to add that mass of the hiker plus the mass of the rucksack, and you're given gravitational field strength. So you do weight equals mass times gravity, so the total mass is 100 kilograms multiplied by 9.8, and so that is 980 newtons. Number 5, same thing, weight equals mass times gravity, calculate the weight force, and you're given the mass, this time in grams, so you should notice that and you think I've got to convert that to kilograms. So 500 grams is 0.5 kilograms, so you divide by 1000 and you're given G 9.8. Again, it should say newtons per kilogram, it's just a typo. So you do 0.5 times 9.8, and that gives you 4.9 newtons. Okay, question 6. So you're using the same equation, you're calculating the weight force, given your mass, which is only 2 grams, and you're given gravitational field strength. So you've got to remember that when you put your mass into the equation, you don't write 2 grams, you've got to divide by 1000, so that is 0.002 times 9.8, and that gives you an answer of 0.0196 newtons. Question 7. You're given the weight force this time, and you're asked to calculate the mass. So you put a box around the mass, and you're given gravitational field strength. So you put your numbers in, 137 is equal to the mass that you don't know, multiplied by 9.8, and then to work out the mass, divide both sides by 9.8, and so your mass is 13.98, and it should be kilograms. Okay, question 8. So you write out your equation, you read the question, you're given the mass of the astronaut, 120 kilograms, and you're given the force on the planet, 247. So their weight when they're standing on the planet is 247 newtons. you've got to calculate the gravitational field strength. So you've got to find G on that planet, and you've got to give your answer to 3 significant figures. So you put your numbers into your equation. The weight is 247. That is equal to 120 times gravitational field strength of the planet. So you do 247 divided by 120, which gives you 2.0583. You've got to give your answer to 3 significant figures, so that is 2.06, and gravitational field strength is newtons per kilogram. Question 9. Write your equation down and study the question. So you're given the mass of the space probe. It's just hovering above the surface of Jupiter, and it gives you the weight force. Again, you've got to find gravitational field strength. You're given the weight, but it's in kilonewtons, so you've got to convert that to newtons by multiplying by 1,000. So 1150 equals 50 kilograms times gravitational field strength. So it's 1150 divided by 50, and that gives you 23 newtons per kilogram.